a monstrous black hole has been spotted feasting on what appears to be the universe's largest donut, around 47 million light-years away. Experts use advanced telescopes here on Earth to capture the massive beast's feeding frenzy, taking place at the center of the spiral galaxy M77. They found a huge cloud of gas, stretching 40 light-years wide, or 235 trillion miles, giving its structure the appearance of the gigantic ringed confection. Studying the phenomenon could help us to better understand the formation of galaxies and the supermassive black holes that develop at their cores. Scroll down for video. A team of researchers, including from the National Observatory of Japan in Tokyo, used the world's most powerful ground-based telescope, the Atacama Large Millimeter / submillimeter Array, Alma, Observatory in Chile, to make the finding. Almost all galaxies hold concealed black holes at their center. Researchers have known for a long time that the more massive the galaxy is, the more massive the central black hole is. Host galaxies are 10 billion times bigger than their central black holes, so it should be difficult for the two objects to directly affect each other. To discover how such a relationship could develop, the Japanese team trained Alma's high-resolution imaging on the center of M77. The central region of M77 is an active galactic nucleus, AGN, which means that matter is vigorously falling toward the central supermassive black hole and emitting intense light. AGNs can strongly affect the surrounding environment and are important objects for solving the mystery of the co-evolution of galaxies and their black holes. The research team found a dense cloud of spinning gas, whose shape is technically known as a torus, surrounding M77's black hole. The existence of these clouds of gas has been theorized for decades, but this is the closest look yet astronomers have been able to take. Masatoshi Imanishi, the study's lead author, said, to interpret various observational features of AGNs, astronomers have assumed rotating donut-like structures of dusty gas around active supermassive black holes. This is called the unified model of AGN. However, the dusty gaseous donut is very tiny in appearance. With the high resolution of Alma, now we can directly see the structure. The Milky Way galaxy that we call home also has a supermassive black hole at its center. This black hole is, however, in a very quiet state and only a tiny amount of gas is being sucked into it. To investigate an AGN in detail, astronomers need to observe the centers of distant galaxies. M77 is one of the nearest AGNs, which makes it an ideal candidate. Numerous astronomers have previously peered into its center, but the rotation of the gas donut around its black hole has never been seen so clearly, researchers say. Besides the superior resolution of Alma, the choice of what type of molecules being emitted by the celestial phenomenon to observe was key to revealing its structure, according to the team. They chose to observe specific microwave emissions from hydrogen cyanide molecules and formylions. These molecules emit microwaves only in dense gas, whereas more frequently observed carbon monoxide emits microwaves under a variety of conditions. The torus around the AGN was assumed to be very dense, and the team's strategy proved this theory was right on the mark. Previous observations have revealed the east-west elongation of the dusty gaseous torus, Dr. Amanishi added. The dynamics revealed from our Alma data agrees exactly with the expected rotational orientation of the torus. Interestingly, the distribution of gas around the supermassive black hole is much more complicated than a simple unified model would suggest. The torus seems to have an asymmetry, and the rotation is not just following the gravity of the black hole but also contains highly random motion. These facts could indicate the AGN had a violent history, possibly including a merger with a small galaxy. The full findings of the study were published in the Astrophysical Journal Letters.